Okay, grade 12s. Let's have a look at the graph of a horizontal shift. For example, let's take y is equal to sine x plus 30 degrees. Okay, and we want to sketch this graph for the interval of minus 30 to 330. Now, what this really means, it's like the other graphs, the parabolas, the hyperbolas, the exponentials. There is going to be a shift of 30 degrees to the left. How I do it is I put the x plus 30 equal to 0, like I do with the parabolas and the other graphs, and I get x is minus 30. Okay, so in other words, if you take your basic sine curve, let's just draw it in quickly and see what happens to our critical points there. Okay, so here's your basic sine curve, and let's draw it in there. What I'm going to do is I'm going to use a different color firstly. This point is shifting 30 degrees to the left. That point shifts 30 degrees to the left. This one, 30 degrees. That one, 30 degrees, and this one 30 degrees. So you have a horizontal shift. Your sine curve shifts 30 degrees to the left. And notice it's from minus 30 to 330. You can, of course, continue this graph if the restriction was, say the restriction, say they said to you that was 360, let's say. Okay, so they said that's 360 there. Okay, what we would do there, if I just do it in the same color, that's the sine of 360. That's great, because what will happen here is that you would actually simply move it you'd actually extend this piece to here, and you'd go there, and of course you could then of course get you could get that end point there, and if you look at that you could work it out in the calculator as well and get it'll probably be around about a half. So you can extend it, but of course in our case we only want it from up to that point there. Okay, alright, so that's a shift of 30 degrees left. The amplitude is going to definitely be 1. The amplitude is 1. Alright, the period is still 360. You're just simply shifting the sign from to the left. Okay, 30 degrees to the left. Alright, what if we sketch another graph quickly? Let's have a look if we go to the right. What about a graph like cos x minus 60? Let's have a look at this. Okay, so here we go. Let's have a look. If I said to you y is equal to the cos of x minus 60 degrees, x minus 60 degrees, and the restriction we can go say 60 degrees to 420. Well, what's going to happen here? Well, what we're doing is we're going to shift the cos graph. We shift the cos graph 60 degrees to the right. How I do it is I put that little x minus 60 equal to 0, and I see I'm at positive 60. I'm shifting to the right. So let's draw our cos graph. I'm going to do these nice and big, these points. And there we go. So we've got that graph. So there's your basic cos curve coming down like this. What a pleasure. And we've got it there. Now we're shifting these points 60 degrees to the right. So that point shifts there. That point shifts by 60. This goes by 60. That by 60. And this by 60 there. So look at your cos curve. It actually goes like this. Comes down. And up we go. So it's really the cos curve shifts at 60 degrees right. And I've got the interval there. Of course, you can extend this now. If you have a look at cos, it normally would have gone to minus 90. And you could have then carried that further there. So it would have come down, and so you go for it. But that's the basic idea of these graphs. Remember, you can extend it, so you can do that if you wanted to. Bring it down, and off we go. There we go. And it carries on if it was from naught, say. Okay, so that's the important thing about horizontal shifts. Exactly the same as parabolas, hyperbolas, and exponential graphs. Okay, but now sometimes what we do is we want to combine all the shifts. Okay, now here's an interesting one. Have a look at this. If you have a look at this graph, let's say for example I gave you to sketch, I said sketch the graph of fx. Now watch this, is 3 sine a half x, and we're going to go for the interval minus 180 to 360 degrees. Okay, now what do we have here? Well, firstly, this 3 tells me there's an amplitude shift. That's an amplitude shift. Okay, so the sine graph will stretch. But look at this. This here tells me that there's a period shift as well. Okay, so let's start off with the period shift. So what we're going to do is we're going to do a period shift with this graph, and then what we will do is we're going to then simply do an amplitude shift on that. So let's have a look. So if we take our period of this graph, now watch out. The period of sine is 360 degrees, and we're dividing by a half, which of course comes to 720. So what's very interesting about this graph is that the sine curve, if you look at it, if we take our basic sine curve, which is 0, 90, 180, 270, and 360, what happens to sine in this case? Have a look here. Not only is it going to have a period shift, but this period shift is 720. So what actually happens with this is that these points stretch. So the naught stays. You've got 90 multiplied by or divided by half is the same as multiplying by 2. 90 goes to 180, so this shifts to there. And then if you look at that, and then of course the 180 shifts to there. So in other words, what you're getting is this effect. Look at that. In other words, it elongates. So what happens is with your sine curve, if you have a sine curve that's doing this, let's just have a look here. You normally would have it going like this. The sine goes like this. Okay, but now what we're actually doing is we're stretching it to a period of 720. So it actually goes like this. Look at that. It stretches out. So it could either could stretch sort of. It's really I'd say a horizontal stretch, either stretching inwards or outwards, and that goes there. And then the other thing, once we've got that, once we've got the sine curve, once we've stretched this, we can then go 3. So that thing shoots up there, and I'm going to do it in a different color. Watch here. That goes to 3, and then it goes up like that. You see, so we have a period shift and elongating thing, and then that can go all the way down to here as well if you extend it. Do you see? So how did it work? You had your sine curve. Okay, let's go up to 360 there, and then we can carry on to 720 there. Now watch this. Okay, there's 1, 2, 3, 1, 2, and 3. So what actually happened here, if I just put a little dot, I just want to just do it very quickly here. Your sine curve would normally have done this. This is your sine curve. There it is. Now we elongate it so it goes like that to there, down to there. You see that there? And then down to here, and up again to there. And then we stretch it up. You see that there? Then we stretch it up. Okay, but we only really wanting, we only want this area there, so we're not really interested in that. Okay, so let's clear it. Just that piece, you see. Alright, so be careful with that. And I just love this graph. It's just such an amazing thing. Okay, so people, I think it's time to practice the horizontal shifts a little bit, but I want you to master these principles of, especially if they mix the shifts. You get like a period shift with an amplitude shift, or you could get an amplitude shift with a vertical shift. There's all sorts of things that can happen there. But let's have a look at this practice example quickly. Okay, sketch the graphs of the following. Here it is, y is equal to sine x minus 30 and cos x plus 30. Have a go at those graphs there. Okay, do you want to sketch them? Alright, where's the sine curve going? The basic sine goes from there to there to there to there to there. Great. And what does this tell us? This is going to be a shift of, like the other graphs, of 30 degrees to the right. So if we draw that, I'm not going to even draw my sine curve. I'm going to shift these 30 degrees to the right. So it goes there. There we go. And this one goes to there, 30 degrees, 30 degrees, and off we go. So the sine curve does this. It's shifted 30 degrees to the right there. Let's just tidy that up a little bit there. Make it look nice here. Here we go. Down we go to there. And up we come. So that's that graph there. Of course, you can continue it because there's, I think the restriction, if you look at this, said from minus 30. So you'd actually come down like this. It comes like that. You see, you can obviously work out that y-intercept there by letting x be 0 degrees, and off you go. And there's your graph. Okay, now what about the cos of x plus 30? What would this be here? Well, that would be 30 degrees to the left. Okay, so how do we do it? Let's draw our basic cos curve. Our cos curve goes there, 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 and there. And what are we going to do? We're going to shift it, this thing, we're going to shift it 30 degrees to the left. So if we go another color, your cos graph goes to there, 30 degrees left, off we go to there. Now look at this, the graph comes down, turns there, up we go, and look at that there, what a pleasure. There's your cos curve. The cos of x plus 30, a 30 degrees shift to the left. Okay, and if we go to minus 30, that's great, we're there, we come down and we go all the way. And in fact, if they said go to 390, I think in this case, let's have a look here. 390, we could just continue the graph and go down there. Okay, so there we go, people. That's a very important lesson on grade 10 and 11 trig graphs. In the next lesson, we're going to do points of intersection of two trig graphs and bring in your matric section on compound and double angles. So stay with us on Cell School.